Hi everyone, in today's lesson we're going to review for the test. Let's read question by question. So I'll start with number 1. Max has averaged a 60 on his last 4 quizzes. What would he need to get on the next 2 tests to have a passing test average of 65? Now I know it says tests and quizzes, but we're going to all assume that they're the same thing. So I may not know the answer right away. So what I'm going to do is I'm going to take apart the question in pieces. I know that Max has averaged a 60 on his last 4 quizzes. So I know that average is defined as the sum of all the tests over the total number of tests. In this case, we only have 4 tests, so the total is 4. The sum of the tests we don't know, which will make x, and the average that he got on those 4 tests is 60. So if I cross multiply, I'll be able to find the sum of all 4 tests, which in this case is 240. Now let's use this information to help us answer the second part of the question. He now wants to know what he needs to get on the next 2 tests so that his average is a 65. So we know again that the average is the sum of all tests divided by the total number of tests this time, which should be 6. So his average is 65 equals the sum of all 6 tests divided by 6. We cross multiply and we get y is equal to 390. Okay, now this 390 represents the sum of all 6 tests. So if this is the sum of all 4 and this is the sum of all 6, all I need to do is subtract them and then get the sum of the next 2 test scores. So Max would need his next 2 tests to add up to 150 points. Now, this could be, he could have one test of, here, I'll put it over here. He could have one test of 100, another test of 50. He could have 2 tests of 75, or any other combination that you can think of. We definitely can't find out exactly what each test would be, but we can find out their sum. So that's enough. So the answer is 150, is that the sum of the next 2 tests would have to be 150. Okay, let's move on to example number 2. It says here, the table below represents the frequency scores on a 20-point question quiz. Part A, if the average number of points is 18, find out what K is. Well, let's first analyze what we're given here. We're given that the number correct out of 20 was either 15, 16, 17, 18, 19, or 20. And the frequency, the amount of times that this happened in the class, was 2, 4, 7, 13, 5, and K we don't know. So normally we would take, if we wanted to find the average, we would add them up and divide by however many we have. So again, average is sum divided by the total. The frequency is the total number. So let's put that here. Frequency is total. Okay, and the sum would be just adding everything up. So I need 2 15s, 4 16s, 7 17s, 13 18s, K 19s, and 5 20s. Now I don't want to write 15 twice when I'm adding it. So I'm just going to write, notice how I did here, 15 times 2, and then so on and so on. So this would be my total sum. Now to find the frequency, we would add up all of these, including K and 5. That's how I got this. And it tells you that the average is 18, so that goes there. So all I did really was put this into the calculator. I put all of this, and I added it, and I got 547. Added to 19K, and then on the bottom I did all of this and this added together, and I got 31 plus K. And then I really just cross-multiplied, and I did some algebra, and after I cross-multiplied, I got K was 11. All right, so that means 11 people in the class got a score of 19 out of 20. Okay, so now what we have to do is find the mode and the median. The mode is easy to find because the mode is the one that appears the most, or the one that's most frequent. And the one that's most frequent is the one that has a frequency of 13. So the mode is actually 18. A score of 18 showed up the most. Now the way that we would find the median is by putting this into the calculator, putting the correct number into L1, and in the frequency put L2, and you would hit one var stats and scroll down to find the median, and the median would be 18 as well. Okay, let's move on to example number 3. Maria asked 2 friends in each of her classes what their math grade was. The following is a list of their grades. Determine each of the following to the nearest tenth. Okay, so these are the intervals at which the students got a score, and this is how many students got that score. Now remember, when we use the calculator and we're putting in L1 and L2, there's no way that I have the ability to put an interval in these data values for L1. The frequencies are easy. I could do 3, 8, 6, 2, 1. But now instead of putting in the entire interval, say 90 to 99 right here, we're going to take the average of 90 and 99 and divide it by 2. So I'll show you how I did that over here. So 90 plus 99, add that up, divide it by 2. When you do that, you get 94.5. So that would be the first value that would go here. And if you notice, I did all the other averages here. So then the second one would be 84.5, the third one 74.5, and so on and so on. So this is the list that would go in your calculator. When you're looking for the mean, you're looking for the X bar. When you're looking for the median, you're looking for the words MED. The interquartile range is Q3 minus Q1. So these are the Q3 and Q1 values. I just subtract them. The standard deviation, you're looking for SX this time, not sigma x, because this is clearly a sample. Maria is asking 2 of her friends in each of her classes. She's not asking all of her friends, so it must be a sample. And variance is defined as the standard deviation squared. So all I did was take 10.5 and square it, and these are the answers that I got. Okay, let's move on to example number 4. Okay. The SATs given in December had a mean of 1,000 and a standard deviation of 150. The SATs given in January had a mean of 950 and a standard deviation of 120. Assume the scores are normally distributed. Marissa took the test in December and scored in the interval 900 to 1100. What is the probability to the nearest 10,000, or 4 decimal places, that a test paper selected at random from the December version scored in the same interval? Well, in order to find the probability, we're talking about area under the normal curve. So we have a mean and we have her 2 data values, and we want to find the area or the probability that somebody would score between those values. So we know we're going to have to use the normal CDF button in the calculator. Remember how we get there is we hit second vars. Okay. So in order to put this stuff into the calculator, the lower limit and the upper limit, you need a z-score. We have data values right now. We have the score of a 900 and a score of 1100. We need to put our z-scores into the calculator. We can't put 900 and 1100. So the way that we find a z-score, just to remember, is your data value minus your mean over my standard deviation. Okay, so if I want to convert 900 to a z-score, I'm going to take 900 minus the mean, which is 1,000. We're talking about the December score, so we have to have a mean of 1,000 divided by 150. You will get a repeating decimal. Your repeating decimal should be about 0.6. But to be as accurate as possible, anytime we have a repeating decimal, we never want to round it. We want to keep it as a fraction. So our z-score over here is negative 2/3. That's my lower number. Now to find my z-score for my upper limit, I'm just going to take the data value of 1100 minus 1000 over 150. And again, this time you'll get 0.6 repeated. Oh, I'm sorry, this one's negative. But like I said, you'll get a positive 0.6 over here, so 2/3. Again, because it's a repeating decimal, we're not going to use decimals. So in my lower value in the calculator, I'm going to put negative 2/3. The upper value, I'm going to put 2/3. And remember, this 0 and 1 never changes. Okay, so in the calculator, after you hit enter, you should be getting a probability of 0.4950. That means approximately 50%. And I mean, doesn't that kind of make sense? 50% scored within this interval. Well, that's what the mean is around. It's very close to the mean, so it should be very close to about 50%. Okay, let's look at part B. It says here that Gabby took the January exam. Within the January exam, there's a different mean and a different standard deviation. The mean is 950, the standard deviation is 120. So in what interval must Gabby score to claim that she did as well as Marissa? Well, in order for her to do as well as Marissa, she would need to have the same shaded area. She would have to have that same probability. So we know what Marissa's z-scores are. Marissa's z-scores that we just found out were negative 2/3 and positive 2/3. So what we're actually asking to find is the interval that Gabby scored. We want to find her data values. So what score does she have to get over here and over here, such that her mean is 950. So we need to get Gabby's data values. So we're going to use the formula that z is equal to the data value minus the mean over the standard deviation. So notice, instead of z, I put negative 2/3. The data value is unknown. I want to find what her data value is with the mean of 950 this time and a standard deviation of 120. So if you look to see what I did here, I honestly just cross-multiplied and solved for x. And when I did that, I realized that her lower limit of the score should be about 870. And then I did the same exact thing on this side. Well, I said that she needs a z-score of 2/3. We want to find a data value, given a mean and a standard deviation, and I just solved for x. So this upper limit is 1030. So Gabby must score between an 870 and a 1030. Okay, let's move on to question number 5. So it says a swimmer named Amy specializes in the 50-meter backstroke. In competition, her mean time for the event is 39.7 seconds, and the standard deviation of her times is 2.3 seconds. Assume that Amy's times are approximately normally distributed. So part A, using z-scores in a graphing calculator and rounding your answers to the nearest thousandth or 3 decimal places, find the probability that Amy's time in her next race is between 37 and 44 seconds. Well, it helps if you draw a normal curve, and helps if you put the mean here and the values that you want to find the probability between. So we want to find the probability that Amy gets between a 37 and a 44. So we want to find the area under this normal curve, with the 37 being the lower limit and 44 being the upper limit. But if you remember, we said that these lower and upper limits must be z-scores. They can't be data values. So we want to find the equivalent z-score for 37 and the equivalent z-score for 44. So if you take a look at the formula that I plugged into, I here did the data value that I want to find, which is 37, minus the mean, which is 39.7, over the standard deviation of 2.3, and got myself a z-score of negative 1.17. So I'll go ahead and put that in here, negative 1.17. And to find the equivalent z-score at a data value of 44, I'll do the data value minus the mean over the standard deviation, and I get 1.87. And again, if I want to put in to the calculator, I'll hit normal CDF. The lower number will be the lower z-score. The higher, or the upper number, will be the higher z-score. And the mean and the standard deviation stay 0 and 1. And if you hit enter, you should get about 0.848. Okay, let's move on to part B. Part B says the same thing. Using z-scores in a graphing calculator and rounding your answers to the nearest thousandth, find the probability that Amy's time in her next race is more than 45 seconds. So again, it helps if you draw a picture with the mean in the middle and the 45 seconds after the mean, because it obviously is after. Your mean is 39.7. So I want to find the probability that she will finish the race in 45 seconds or more. So the way that we do that is, again, find the corresponding z-score to this data value of 45. Because in the calculator, we must put z-scores for my upper and my lower. Okay, so if I want to find the z-score for the data value of 45, the formula is data value minus the mean over the standard deviation, and you get about 2.30. So that is my z-score over here, 2.30. And we want to find the shaded area to the right. Now we say that this would go on to infinity, but it's enough to put 5. Most of the data is covered at the z-score of 5. So we put these 4 values into the calculator, and we should get 0.011 for my probability. Okay, let's move on to part C. Part C says, what is the probability, rounded to the nearest hundredth, that Amy's time will be at least 45 seconds? Being at least 45 seconds means 45 seconds or more. So this is really the same way as asking part B. So I'll just use the same answer, but actually I noticed here that it should be rounded to 0.01 because it says to the nearest hundredth. So same question, just worded a little differently. Okay, now part D. They want you to find the probability that Amy's time in the race will be less than 36 seconds. So here's where 36 seconds would lie, because her mean is 39.7, so it's a little bit smaller than the average time. And we want to find the values that are less than this. So my lower limit is going to be approximately a z-score of -5, because it's our negative infinity, goes to about a z-score of -1.61, and the mean is 0, the standard deviation is 1, so we put this information into the calculator, and to the nearest thousandth, you should get about 0.054. Okay, now for number 6. I'm going to read along here. A doctor noticed that many female patients were vitamin D deficient. She would like to determine what proportion of her patients are deficient. So she chooses a random sample of 45 medical files of female patients and finds that 37 of these patients are vitamin D deficient. So the first thing is find the margin of error in her findings. Well, the margin of error, anytime you're given a proportion, is 2 radical p 1 minus p over n. Now, you might be saying, well, I wasn't given a percentage or a proportion, but you can find it. You were given that 37 out of 45 female patients find that they are vitamin D deficient. This is about 82.2%, or approximately 0.82. So that is what my P is going to be. My N is the 45, the total number of people. So all I did was just put this into the calculator, and I got 0.11. So that margin of error tells me how far off this sample is from the actual population proportion. So if we want to find the interval in which the population proportion would exist, where all of her patients we could find out who are deficient, we just take the sample proportion and subtract the error, and take the sample proportion and add the error. So the sample proportion is 0.82 in both cases, and subtract and add 0.11, and we get that our population interval should be between 0.71% and 0.93. So about 71% to 93% is where the population proportion would lie. And that's it. Okay, let's move on to question number 7. Okay, so in question number 7, it says, use an exponential regression to find the function that models this data, rounding all values to the nearest hundredth. So to get this equation right here, what I did was I used the list in the calculator, and I put time in L1, and I put the population in L2. Once I did that, I followed the steps in my calculator and hit exponential regression. When I did that, I was able to get these values for A and B. So take a minute, see if you can get that. All right, and now it says, when will the population exceed 50,000? So you don't have to put 50 and then 3 zeros. You don't have to put 50,000 because these population numbers are already in thousands. So since that is your y value, you're going to put the 50 here, and we want to find x, the time that it will take for this to happen. So I know that when I'm trying to find an exponent, I have to use logs. And when I use logs and I'm trying to find an exponent, I have to isolate the base with the exponent. So I divide 0.904, and this is what I'm left with. Then I log both sides, drop the power like it's hot, and now I can divide by log 1.03 and get my final answer. Now, if you got something a little different than this, you need to make sure that you're using all of these decimal values. So when you do 50 divided by 9.04, you'll get this decimal where you have a whole bunch of other numbers. Don't hit clear, hit log of answer, so you have the whole entire decimal. And you should get about 58 years. Okay, part B is asking, what will the population be after 100 years? So they want to know what is y, what is the population, when time or years is 100. So all you got to do is plug in 100 for x, plug this into the calculator just the way you see it, and you get approximately 173.7 thousand people. So we could write this as 174 approximately thousand if we wanted to. Just saying. Okay, let's move on to question number 8. All right, I'm going to read this question a little bit on the slower side because this is a lot to take in. Okay, Stevens Beverage Company is considering whether to produce a new brand of cola. The company will launch the product if at least 25% of cola drinkers will buy the product. 50 cola drinkers are randomly selected to take a blind taste test of products A, B, and the new product. 9 out of 50 participants preferred Stevens' new cola to the products A and B. The company then devised a simulation based on the requirement that 25% of cola drinkers will buy the product. Each dot plot in the graph below represents the proportion of people who preferred Stevens' new product, each of sample size 50, simulated 100 times. Okay, so now part A, I guess. Assume the set of data is approximately normal and the company wants to be 95% confident of its results. Does the sample proportion obtained from the blind taste test, 9 out of 50, fall within the margin of error developed from the simulation? Okay, this sample proportion of 9 out of 50, I did the work over here, is approximately 0.18, so approximately 18%. We want to know if that number falls within the margin of error developed from the simulation. So I'd like to draw your attention now to the simulation. I need to find the margin of error from this simulation. Now they give you a mean and they give you a standard deviation. So when they give you a standard deviation, the margin of error is simply 2 times the standard deviation. So if we take 2 times 0.062, we get approximately 1.124. This is the margin of error. So what we need to do to find the population proportion, what we would have to do is take the mean minus the error, the mean plus the error. So here's the mean, 0.247, add the error and subtract the error, and this would be the interval in which the population would lie. So let's just write it, and rounding to the nearest hundredth, it would be 0.12, so 12% to 37%. So I'm going to read the question again. Does the sample proportion of 0.18 obtained from the blind test fall within a margin of error developed from the simulation? Well, this is the margin of error, 0.124, from the simulation. This is the population interval that it would be using the simulation. And doesn't 0.18 fall right in the middle of it? So 0.18 is definitely inside the data value there. So I said over here, yes, 0.18 falls inside the interval. Okay, now let's read the second part. The company decides to continue developing the product even though only 9 out of 50 participants preferred its brand of cola to the taste test. Describe how the simulation data could be used to support this decision. Well, okay, so this is what I wrote. I said that the company already has evidence that the population proportion could be at least 25%. The dot plot, however, shows, I'm not even going to put that, the dot plot shows the sample proportion of 0.18 or less very few times. The simulation shows 0.25 or more many times. So what do I mean by that? I mean, even though they said 0.18 was 9 out of 50 people that took this survey or taste test, do you see how 0.18 or fewer proportions appeared less? So this simulation is a better representation of the real data, that you see how they've simulated a few times and there are many values over 0.25. So this 9 out of 50 was not enough to convince them. So I agree that they should definitely continue the product. Okay, let's look at number 9. So given the following equation of the parabola, determine the focus, directrix, and the vertex. So just as a refresher, here's the formula. It goes x minus h squared equals 4p y minus k, where the vertex is found by negating the values of h and k. So negative 4 and 2 become positive 4 and negative 2. So that is where I just drew a sketch over here of 1, 2, 3, 4, positive 4, negative 2. And since my p value, or my number in front here, 8, since it's positive, I know that my parabola has to open upward. So if it's opening upward, that would mean that my directrix has to be below it. Now, the p-value in the formula, do you see how this 8 and 4p are in the same spot? So that must mean my p is 2. So all I did was take my vertex, go down 2 values, go up 2 values. So therefore my focus is in the inside and my vertex is right there. So the directrix line is the line y equals 4, and my focus is 4, 0. Okay, let's look at number 10. At the local swim club, owners use the local fire department to help fill their pool. A small truck can fill the pool in 8 hours. The larger truck can fill the pool in 5.5 hours. How long would it take the two trucks if they work together? These are the proportions or fractions that you need to set up. The smaller truck can do 1/8 of the job in an hour, where the larger truck can do 1 over 5.5 of the job in an hour. Together, they'll only be able to do 1 over x of the job. So, the way that we set up the equation is very simple. 1 over 8 plus 1 over 5.5 equals 1 over x. And first we need to make a common denominator. So this 8 needs both the 5.5 and the x. This 5.5 needs the 8 and the x. And this x over here needs both the 5.5 and the 8. So I cross off the denominator once they're the same, and I just simplify the numerator. So 5.5x goes here, 8x goes here. I multiply 5.5 times 8, and I put that there. And now I just solve algebra. So it doesn't say what to round to, but we will say approximately 3.26 hours. Okay. Example number 11. The data in the table represents the average daily temperatures in degrees Fahrenheit for a city over a 12-month period in the year 2015. So here's the month, here's the temperature. So we're first going to put this into L1 into the calculator and the temperature into L2. Now, since I want to find a sine regression, we need to first make sure the calculator is in radians. So make sure calculator is in radians. Okay. Once you do that, you're going to hit stat, go over to calc, and find sine regression, and hit enter. Okay, so this should be your A value, this should be your B value, this is your C, and this should be your D in your linear regression, your sine regression. Now, based on this equation, state the expected temperature. Temperature is a Y value. So whatever goes here is X and whatever is there is Y. So we want to find the Y value in April of 2016. This is a 12-month period for 2015. So 2015, 1 represents January and 12 represents December. I want to go into the next year. So I have January, February, March, and April. I have 4 more months that I need to add to this to get to 16. So 12 plus 4 is 16, and 16 represents April of 2016. Okay, so all you're going to do is plug 16 into X into the calculator, making sure you are in radians. And once you do so, you should get about 35.8 degrees Fahrenheit. Okay, what is the amplitude of this function? The amplitude is the value in front. Value in front is 35.5. That is it. Okay, now it's time to solve the system by elimination. So normally what we do is we take the first 2 equations and we set them up over here. Then we take the second 2 sets of equations and set them up over here. And we're going to try to eliminate one of the variables. So what I did first was I tried to eliminate the x's. So I put the 5 up here and the 2 down here. And I know that one of them needs to be negative so that when I add them they have opposite signs and they cancel. So all I did was I took this 5 and distributed it out to every piece here and got this equation. I took this -2 and distributed it out to every piece there and got this equation. Then I simply added these 2 things together. So 10x plus -10x canceled. When I add these 2, I got -9y. When I added these 2, I got 11z. And when I added these 2, I got 13. Now on this side, we're going to eliminate the same variable. So I wanted to eliminate the x's. So I put the 2 up here, I put a 5 down here, and one of them needed to be negative so that when I add them, they cancel. So again, just like I did before, I distribute the 2 to every piece in here and the 5 to every piece in here. And when I did that, I got these values here and these values here. I add, these cancel. I add, I got negative 1y, negative 1z, and negative 8. Okay, now after I've eliminated one variable, I'm going to take these two equations and put them on top of each other so that I can eliminate one more variable, the y's. So what I did was I took the 1 and put it up here and the 9 and put it down here. Now one of them still has to be negative. Even though they're both negative, consider it like they're on the same playing field. They're both positive or both negative. They have to be on opposite so that I can cancel. So when I distribute all this, I should get this. And when I distribute 9 into all this, I should get this over here. So negative 9 times negative 1 is positive 9. So you see how now these are opposites? So that when I add them, they cancel. When I add these, I get 20. When I add these, I get 85. So now some of you may have already answered this and were like, oh no, I got a fraction, it's wrong. But actually it's not. 17 over 4 is the correct answer. If you got the decimal equivalent, just double check to make sure it's the same fraction. Okay, now after I find 17 over 4, I have to plug that z value into one of these two equations from up here. I chose, I think, this equation and plugged in my z value and solved this equation and got a y value. So now y is 15 over 4. And now that I have an x value and a y value, I'm sorry, not an x, a z and a y, I take both of these two values here and here, and I'm going to plug them into one of the original three equations. I chose the first one, so I did that and rewrote it right down here, and I plugged in the y that I got and the x that I got, z that I got, and I solved for x. So I'm going to add these two things in the calculator, and I got 1/2, subtract 1/2, divide by 2, and I get 5 over 4. So if you had some difficulty with this, what I would suggest that you do is take your time, copy down the problem, copy down the question, make sure you're careful with your positives and negatives. That's the only thing that I can suggest for this one. Okay, now it's time to determine algebraically if the following function is odd, even, or neither. Now remember, the only way we could tell algebraically if a function is odd, even, or neither is if we plug in negative x into the original function. If all of the signs become changed, we're going to say it's odd. What would we say if it's even? If it's even, let's write this down, the equation would be exactly the same. So we would get the same equation. Okay? So let's see why this is an odd function. So when I plug in negative x, I got negative x to the 7th. What I simplified that to is negative x to the 7th. It means the same thing because negative x to the 7th power means negative x times negative x 7 times. Okay, so these two make a positive x squared. These two make a positive x squared, and these two make a positive x squared. And if you multiply all three of those together, you get x to the 6th, and you want to multiply it by one more that's left over, so negative x. So this will be negative x to the 7th. Same exact concept, okay? So anytime you have an odd power, it's always going to be the negative. So this reduces to that. And again, negative x to the 3rd, same concept, goes down to a negative, so negative 6x to the 3rd. And a negative 2 times a negative 1 is a positive 2 here. So all of the signs from the original were opposite. So since they're opposite signs and they've changed, we say the function is odd. Okay, now what we're going to do is solve this radical equation for number 14. Before we can solve the radical equation, we have to isolate the radical so that it's the only thing on one side of the equal sign. So if you notice, what I did first was that I subtracted 5. So I subtract 5, and I got x plus 1 under the radical equals negative 5. To get rid of the radical, you have to square it because the radical and the square root cancel, and I'm left with x plus 1 equals 25. Simply to solve for x, you just subtract 1 and you get 24. Now, some of you that don't check would just say, okay, 24 is the answer. But technically, there's no solution because when I check, it actually does not work. So I get radical x plus 1 plus 5 equals 0. Plug in 24. Square root of 25 is 5. 5 plus 5 is not 0. So because it does not check out, there is in fact no solution. So be very careful when you are checking. Okay, that about covers the review for tonight. I hope that everyone is studying and aces the test tomorrow. Have a good night.